The cold winds of the North Sea howled across the cliffs of occupied Europe as the war entered its most desperate stage. Somewhere in the darkness, hidden beyond the clouds, a small group of Allied bombers streaked across the sky. Unseen, unheard, yet guided by something new, something invisible. On the ground below, German radar operators scanned their glowing screens, searching for the telltale dots that signaled incoming aircraft. But that night, their scopes were empty. The Luftwaffe's defenses stood blind, wondering why their instruments failed to detect the enemy until it was too late. What the Germans didn't know was that somewhere deep inside an RAF laboratory in Britain, a revolution in radio detection had already begun. And soon, a single captured radar unit, one that fell into German hands by sheer chance, would send shockwaves to the Reich scientific community. Because when their engineers opened it up and saw what was inside, they realized they were years behind and perhaps doomed to lose the war in the air. To understand why that moment was so shocking, we have to step back to a time before radar became a weapon. In the 1930s, radio waves were still a mysterious force. Scientists across the world, from Britain to Germany to Japan, were experimenting with them. They discovered that radio signals could bounce off aircraft, allowing one to see through darkness or fog. But these early systems were crude. They were massive, slow, and inaccurate. Most had a detection range of just a few miles. In Germany, radar development began early and aggressively. The Reich's engineers, under the Luftwaffe's research office, created a network of powerful ground-based systems. The most famous was called Freya, a giant rotating antenna capable of spotting incoming planes at a distance of about 100 miles. Later, another system called Würzburg provided more accurate tracking. Together, they formed the backbone of Hitler's air defense system. To the outside world, it seemed like Germany led the radar race. Their stations lined the coasts of France, Denmark, and the Netherlands, watching over Europe like an electronic curtain. Allied pilots feared the Freya's unblinking eyes. But in secret, British scientists were working on something that would change everything. Something small enough to fit inside a bomber's nose, yet powerful enough to detect a submarine beneath the waves. It began with an unassuming device called the cavity magnetron. In February 1940, two scientists at the University of Birmingham, John Randall and Harry Boot, produced a breakthrough. Their new magnetron could generate microwave frequencies thousands of times higher than existing radar systems. Suddenly, radar beams could be made narrower, more precise, and far more powerful. What had once required massive towers could now be done with a small dish. This innovation became the beating heart of a new class of radar, one that would soon guide Allied bombers through storms, detect enemy ships at night, and help fighters find their targets in total darkness. But for months, the Germans didn't know it existed. That changed in early 1943. One cold night over the Netherlands, a British bomber, part of a radar-guided night mission, was hit by flak. Flames engulfed its engines, and the crew bailed out. The aircraft crashed into a muddy field near Rotterdam. Among the wreckage was a blackened, compact metal box, a piece of secret equipment that the Germans didn't immediately recognize. It was quickly recovered by Luftwaffe intelligence and sent to a high-security research center near Berlin. There, a team of the Reich's best scientists, radar engineers, physicists, and military officers, gathered around the mysterious box. They carefully opened it, noting its components, the wiring, and a strange circular metal device in the center. At first, they assumed it was just another Allied radio. But then they realized something extraordinary. The device inside, that small, almost toy-like component, wasn't a radio at all. It was a magnetron, unlike any they had ever seen. The German magnetrons of the time were clumsy and inefficient. They could produce a few hundred watts of power, enough for ground-based radars. But this British unit was compact, elegant, and powerful beyond belief. It generated thousands of watts of microwave energy, stable enough to run from an aircraft. As one German physicist reportedly muttered in disbelief, "If this is truly functional, then we are finished." For years, the Germans had believed their radar systems were the best in the world. Now, in the flickering light of a Berlin laboratory, they were staring at proof that their enemies had leapt far ahead, technologically, scientifically, and strategically. Word spread quickly through the Luftwaffe's technical branches. What was this new kind of radar? How had the British miniaturized it so much? Could it be replicated? And if so, was it already in widespread use? The implications were terrifying. If Allied aircraft could carry radar that powerful, it meant their bombers could locate ships at sea, track submarines, and even find German fighters hiding in the clouds. The element of surprise, once Germany's greatest weapon, was slipping away. Meanwhile, in Britain, the magnetron's invention remained the most closely guarded secret of the war. Engineers at the Telecommunications Research Establishment, known as TRE, were producing them by the thousands. American factories, too, had begun mass production after the British shared the design during the famous Tizard mission, a scientific alliance that changed the course of the conflict. By the time Germany discovered the magnetron, Allied aircraft like the Mosquito and the B-24 Liberator were already using it to hunt U-boats in the Atlantic. Convoys that once suffered heavy losses were now protected by radar-guided patrols that could see even in pitch darkness. But inside Germany, scientists were scrambling to understand how this tiny device worked. They disassembled it, analyzed every component, and tried to reproduce it using their own methods. The results were frustrating. The materials required were difficult to find under wartime shortages. The precision manufacturing needed was beyond what most German factories could deliver by 1944. Every attempt to replicate the cavity magnetron ended in partial success. A flicker of energy here, a burst of microwaves there, but nothing that matched the Allied version's power or reliability. And as the Allies advanced on all fronts, time was running out. In the following months, as Berlin's laboratories worked day and night, more radar-equipped bombers appeared over Europe. German night fighter crews reported seeing flashes of detection where none should exist. Their own radar screens lit up with false signals, jammed by Allied countermeasures. The war of radio waves had begun, and the Germans were no longer ahead. By the time they realized how far behind they'd fallen, the outcome of the air war was already sealed. But the real story of how one captured radar unit opened their eyes to a revolution they never saw coming was only beginning to unfold. Inside a dimly lit laboratory near Berlin, the German scientists gathered again around the workbench. The captured Allied radar unit lay disassembled before them, its components carefully laid out on a clean white cloth, as if they were performing an autopsy on some alien technology. At the center of it all was the British magnetron, small, cylindrical, deceptively simple. But to the men in that room, it looked like something from the future. They studied its copper cavities. Precision machine with a level of craftsmanship Germany could barely afford in the middle of a total war. They ran calculations, measuring the resonance frequencies, and realized that the device operated in the microwave band, far above anything their own systems used. One of the physicists, Dr. Ernst Kuhn, scribbled notes furiously in his journal. Compact high efficiency, pulse output impossible, he wrote. Yet, the proof was right in front of him. When they finally connected the device to a test circuit, the oscilloscope burst into life. The readings shocked them, an output power of over 10 kilowatts, in a frequency range of around 10 centimeters. The British had mastered centimetric radar, a leap far beyond Germany's metric wave technology. To anyone outside the radar world, those numbers might mean little. But in practical terms, it meant this. Allied radar could now detect smaller targets with greater accuracy and resist jamming. A submarine periscope, a lone fighter plane, even the outline of a coastline, all could be seen clearly on the radar screen. The Germans suddenly realized why their U-boats were being hunted with uncanny precision, why their night fighters were being intercepted before they even reached the bombers, why their convoys were being bombed from the blackness of the night sky. It was all because of this, the tiny British magnetron. They immediately reported their findings to the Luftwaffe's research division. Meetings were held, memos written, and frantic orders issued to replicate the device. Laboratories in Berlin, Munich, and Vienna were mobilized. The German radar company Gemma received classified instructions to produce experimental versions. But there was a problem. The magnetron's design required not only advanced theory, which the Germans had, but also manufacturing precision on a microscopic scale, which they didn't. Copper cavities had to be machined to within fractions of a millimeter. Vacuum seals had to withstand immense electromagnetic stress. And most importantly, it required pure tungsten and copper, materials that were now critically scarce due to Allied bombings and collapsing supply lines. Even the Reich's best physicists, men like Professor Hans Hallmann, one of Germany's radar pioneers, struggled to make progress. Hallmann's team produced working magnetrons, but their power output was erratic and unstable. The devices overheated, burned out, or produced distorted signals. Meanwhile, Allied factories in Britain, Canada, and the U.S. were churning out magnetrons by the thousands, using precision techniques perfected in American industry. The technological gap had become a chasm. But to the Germans, the discovery wasn't just a technical shock. It was psychological. For years, they had believed they were the masters of applied science. Their physicists had invented the jet engine, the rocket, and the V-2 missile. Now, they were staring at a forward device so advanced that even their top scientists could barely understand it. One intelligence officer reportedly remarked, "It is as if the enemy has leapt a decade ahead overnight." And in many ways they had. The Allies were already using radar in ways the Germans never imagined. In the skies over the Atlantic, aircraft equipped with H-2S radar could scan the surface of the ocean, spotting U-boats before they could submerge. In the night skies over Germany, bombers equipped with AIMK-8 radar could track enemy fighters, allowing gunners to aim through the dark. Perhaps the most chilling moment for the Germans came when they realized something even more incredible. Their own radar systems were being jammed by Allied countermeasures. Countermeasures built upon the same magnetron technology they had just discovered. The Allies had begun using window, thin strips of aluminum foil dropped from aircraft to confuse enemy radar. But now, with microwave radar, they had more sophisticated tricks, electronic jamming signals, radar decoys, and false echoes. What had once been Germany's technological advantage had become their greatest vulnerability. And so, as the war dragged on, the Luftwaffe's night defense system, once so feared, began to falter. British Mosquito night fighters hunted German interceptors before they even reached their targets. Radar-guided bombs and torpedoes made the seas deadly for Axis ships. Everywhere the Germans turned, they were met with the invisible eyes of radar. Inside the laboratories, frustration turned to disbelief, then despair. Engineers worked in freezing conditions, trying to replicate the British magnetron, while Allied bombers shook the ground above them. The irony was brutal. The very technology they were studying was guiding those bombers to their doorstep. But among the scientists, there was also fascination, even respect. Some secretly admired the elegance of the design. One German physicist later admitted that when he first saw the Allied radar unit, he felt a mixture of terror and awe. Interestingly, German intelligence initially thought the captured unit might be an experimental model, a prototype not yet in full use. They assumed it would take the Allies years to field such systems widely. They were wrong. By late 1943, nearly every major Allied bomber was equipped with magnetron radar. U-boat crews began calling the mysterious detection system the Death Ray, believing it could somehow sense them through water. Even when submerged, they felt exposed. The fear was psychological, but very real. As the Allies refined their systems, Germany tried desperately to respond. They developed Neptune, a radar set for night fighters in Berlin, their first attempt at a centimetric radar. Ironically, Berlin was built directly by copying the captured Allied magnetron unit. It worked, technically, but by the time it was deployed in 1945, the war was already lost. Only a handful of aircraft ever carried it. Still, within that small success lay an astonishing truth. Had Germany captured the magnetron earlier, perhaps in 1941 instead of 1943, the balance of air power might have shifted. They could have built radar-guided interceptors, advanced jamming systems, or early warning networks that matched the Allies. But history doesn't deal in ifs. As Allied bombers roared over Europe in growing numbers, their radar systems guided them unerringly through storms, darkness, and clouds of flak. The Germans could no longer hide, no longer surprise, no longer rely on a fog of war. Their scientists had unlocked the secret, but far too late. The war had already turned into a contest of industrial endurance, and the Allies had both the industry and the innovation. Yet the story of that captured radar unit remained one of the most remarkable scientific turning points of the entire conflict, a moment when knowledge crossed the front lines, and one side glimpsed the future just as their own world was collapsing. It wasn't just a discovery. It was a revelation, one that showed how invisible waves could shape the fate of nations. And as the war neared its end, that same technology would open doors to an entirely new age, one that would outlast the empires that fought for it. By the winter of 1944, Germany was burning. Cities that once gleamed with ambition now smoldered beneath the relentless Allied bombing campaign. The night skies above the Reich glowed red, and the sound of distant engines became a nightly omen. Inside underground laboratories and bunkers, German scientists still worked feverishly, hunched over blueprints, test circuits, and the remains of that captured British radar. They were determined to close the gap, to create their own Magnetron, to somehow level the playing field before the inevitable came crashing down. But outside, the world was already changing. Allied bombers now flew with radar-guided precision. No longer did they rely on moonlight or dead reckoning. Instead, H-2S radar painted ghostly images of cities on glowing screens inside cockpits. Rivers, bridges, even cathedral towers appeared as bright smudges on those phosphor displays. Pilots could bomb through cloud cover, through smoke, through the night itself. And somewhere in the blackness above Germany, an invisible war was raging, not with bullets or bombs, but with electromagnetic waves. German night fighters scrambled to intercept, guided by their ground controllers. But those controllers were often blind, their Freya and Würzburg radars overwhelmed by jamming. Pilots shouted into radios that filled with static and false echoes. Their instruments, once the pride of German engineering, had become useless. The Allies were now masters of the invisible spectrum. In a desperate attempt to fight back, German scientists finally completed their answer to the British Magnetron, the Berlin radar. Compact, centimetric, and capable of detecting targets within a few miles, it was a remarkable piece of engineering. But there was a cruel irony. By the time it reached operational status, the war had already moved beyond radar defense. In April 1945, as Allied tanks rolled toward Berlin, the city's laboratories fell silent one by one. Scientists burned their notes, smashed prototypes, and fled into the chaos. Among the documents destroyed were detailed studies of the captured Allied radar, pages filled with sketches, formulas, and annotations that might have changed history had they come sooner. When American troops entered Germany, they found some of those devices still intact. In dusty underground chambers, they uncovered fragments of the Berlin radar sets, experimental magnetrons, and half-assembled antennas. To their surprise, many of these systems were direct copies of Allied technology, proof of how deeply that one captured radar had influenced the Reich's scientific efforts. But by then, the world's attention had already shifted toward the future, because radar, once a weapon of war, was about to reshape the modern world. When peace returned, the same scientists who had built instruments of detection turned their knowledge to exploration. The magnetron, that small device at the heart of the story, found new life in an unexpected form. The microwave oven, the same technology that had once guided bombers to destroy cities, would soon heat dinners in post-war kitchens. Air traffic control systems, weather forecasting, and even space exploration would all trace their origins back to radar innovations of the 1940s. What had been a secret of war became a foundation for peace. But for the German scientists who had once opened that captured unit in awe and disbelief, the memory never faded. Years later, in interviews and declassified reports, some of them described that moment, the first time they saw the Allied magnetron, as the instant they realized Germany could not win the technological war, not because of lack of intelligence or skill, but because of what they called industrial imagination. They had the knowledge. The Allies had the freedom to apply it without fear of hierarchy or politics. One of the captured engineers told Allied interrogators, "We underestimated your scientists. We thought your engineers were only practical men, not visionaries. We were wrong. Those words echoed a painful truth, that innovation in war isn't just about invention, but about how fast you can turn discovery into reality. While the Allies built teams across nations, British researchers sharing secrets with American physicists, Canadian engineers manufacturing components at record speed. German scientists were bound by secrecy, rivalry, and bureaucratic control. Every idea had to climb through layers of command. Every test had to wait for approval. In a race where time itself was the enemy, they moved too slowly. And so, that single captured radar became more than just a piece of hardware. It became a mirror, one that reflected the difference between two scientific worlds. For the Allies, it was proof that collaboration and creativity could win wars. For the Germans, it was the moment they saw how far behind they had fallen. By the end of 1945, radar had proven itself to be one of the decisive technologies of the 20th century, equal in importance to the atomic bomb and the jet engine. It didn't just shape battles. It reshaped how humanity perceived the world. The skies were no longer dark. The sea was no longer hidden. The unseen could now be seen. And it all hinged on invisible waves, silent, fast, unstoppable. There's a haunting image, found in post-war archives, a German engineer standing beside the burned remains of that Allied radar unit, staring at it one last time before surrendering. His face is unreadable. Pride, sorrow, perhaps even admiration. He reportedly said, "We built towers. They built ideas." That single line captures the tragedy of the German scientific effort during the war. Vast talent, brilliant minds, yet trapped in a system that valued spectacle over adaptability. The captured radar didn't just expose a secret technology. It exposed a mindset. And in the quiet laboratories that survived the war, as the world rebuilt from ashes, many of those same scientists would go on to contribute to the very technologies they had once fought against: radar research, aerospace design, even the early stages of computer science. The boundaries of wartime rivalry dissolved into a shared quest for knowledge. But the image of that Magnetron, small, elegant, humming with invisible power, remains one of history's most powerful symbols of technological shock. It marked the moment when the German Reich, confident in its superiority, discovered it had already been left behind by a quieter, subtler kind of weapon: innovation itself. And so, in the final months of the war, as Allied bombers soared above the ruins of Europe, guided by unseen radar waves, the scientists in Berlin finally understood what those glowing screens in British labs truly represented. Not just machines that could see through the dark, but a glimpse of a future they would never control. A future built not by conquest, but by the imagination of those who dared to see farther.